What is going on, guys? Today I'll be starting a brand new series called Functional Python, where I'll be teaching you functional programming in Python. Now, functional programming is one of those things where many programmers know that it exists, but they don't know what to do with it and why it's useful, and it's either too hard for them or they just simply don't have enough interest. Well, let me tell you, functional programming is very useful. And no, I'm not talking about winning code golf competitions. Obviously, you've seen those code golf answers where they type one-liners and then they use functional programming to do so. Yes, that is a bonus point for impressing others. But when I'm talking about usefulness, it's actually has real world implications, especially in the fields of data science, scientific computing, and yes, even artificial intelligence. So when you're doing artificial intelligence algorithms, you're going to need functional programming once you go deeper into the subject. So without further ado, let us get into what functional programming even is. Well, functional programming, by the name of it, revolves around functions, like just everything related to functions. That is what functional programming is. Now, it is built off of these three pillars or concepts, which are pure functions, mutability, and higher order functions. Now, we'll go over that all in today's video. One thing I want to know before we start is that this series does not require any procedural programming or the for loops, the variable modification, and all of that to continue. So if you are actually joining us as a brand new person who learns programming, I applaud your bravery because no one starts off with functional programming. But that goes to say that if you do have any procedural experience with for loops and stuff, be prepared to throw that out of the window. I'm just gonna straight up say that because functional programming is completely different from your normal programming experience. So OOP and all of that, yeah, just leave that out of this because we will be going over concepts completely different from what you've ever learned. So I guess that's kind of the reason why many people don't want to learn functional programming is that it is just way too different for them, and they'll pretty much have to start over from the beginning. But don't worry, I'll go over some of these concepts of functional programming so that you will become a better functional programmer. So again, that was a super long intro, but onto the video, we're gonna go over what these three fundamental pillars are for functional programming. Alright, if you're still with us as of this point, that means that you actually want to learn functional programming. Hopefully I filtered, filter, get, filter function. Hopefully I filter everyone else who doesn't know functional programming, who doesn't care. But if you do care, let's begin with first pillar right here, pure functions. So let's see what this means. Functions that do not modify any state that would cause side effect. What does that even mean? Well, let me give you an example. Think two math functions. The ones that you learned in school. So for example, square is a math function, and it will just return the square of a number. So when we're doing stuff like this, it'll return 16. And if we're doing stuff like this, it will return 25. So let's run that, and boom, 16, 25 right there. All right, seems simple enough. Now, how is this any different from any other function? Well, let me give you an example of an impure function, stuff you might see with like OOP and procedural programming. So impure function, I'll just define this as the impure square, all right? So impure square, we're going to need a product first, and we're going to set that to whatever we want. So this will be kind of the parameter here. Again, this is just for the sake of demonstration. This isn't anything efficiency or anything like that. So when we're doing stuff like this, for example, we're multiplying by 4 each time. When we're running this impure for the first time, sure, it might work. Alright, but for the second time when we run it, it's not going to give us the same result. And third time we run it, it's going to change the results again and again. So once we print product at the end, you can see that hopefully this thing won't error because Spider's giving me like this thing right here. Let's just see if it works or not. And I apparently, okay, yeah. All right, so gotta do something like Python globals or something, global variable in like a function, and then, you know, forgot to do this. Yeah, there we go. Okay, yeah, just ignore that minor inconvenience. But that's not the point. Okay, the point is that this call depends on the previous call, and that is very error prone, because if we have stuff like, multiple product calls, we'll have to basically debug it, and it'll take a super long time to debug. The good thing about functional programming is that pure functions don't require much debugging at all, because you'll know that it doesn't matter if you call this 1 time, 2 times, or 1,000,000,000 times, Square is always going to behave the same. However, this impure function, it's not going to behave the same. Each time, it's going to add on to something different. So that is pretty much going to be why we want to use pure functions in functional programming, especially when you're doing stuff like scientific computation, where you're doing lots of heavy math. You wouldn't want to do stuff like this. You want to do stuff like this. And by the way, this can be reduced to a lambda expression, but I'll show you that in a little bit. But this is kind of like the gist of it, and this is like how we want to use pure functions rather than impure functions. Now, the second thing, again, is immutability, which this also violates, is that you can see that we are updating the product each time. And that is not allowed, because, again, it will cause behaviors that are very sporadic. Basically, we wouldn't really know, in a functional sense, we wouldn't really know what this is doing, and we'll have to debug. Luckily, Spider has this lovely debug feature, Variable Explorer or something like that. But with pure functional programming, this isn't allowed, because you can see data cannot be modified once it is created. Now, clearly, this is modifying the data once it's been created, but this is not, because notice that x is created the moment it gets called. So, like, for example, if we print square of 5, 5 gets passed into the variable x, and boom, it's created within the scope. Obviously, we're talking about scope here, not anything else. But it's created within the scope and gets destroyed at the end of the scope. But you can see we never really set x to anything. If we do stuff like, x equals x plus 1, that will be violating this pillar right here. So that is not allowed. So we must do something like this. And that is also one of the reasons why lambda functions do not allow any reassignments and stuff. So basically, okay, now let's see an example of a higher order function, because these two are pretty simple to understand through these examples. But what even is a higher order function? So let me just create a new higher order function right here, down here, or should I say, higher order functions. And what these are doing is basically you can pass functions into other functions. So kind of like the math composite functions, where it's like f of g of x or something like that. So let's actually do a higher order function in terms of just adding, basically. So we're going to create a higher order function called higher order add, and we'll define an increment, and then within the higher order function, we can have another function called add increment. You can see where this is kind of going, and that will take a nums parameter, and new nums equals a empty list. And I know we'll be using for loops, which is obviously a no-no in functional programming, but this is just demonstrating how higher order functions work. So just yeah. So for all n in numbers, we're going to do new numbers that append n plus increment. So basically, you can see we're incrementing each one of these numbers and then we're storing it into this new nums kind of like array. Now, obviously, this violates the immutability and pure function thing, but I just want to show you a simple higher order function because usually it's harder to understand these type of functions. So that's what I'm doing. So you can see we have a nested function going on here, and then we'll just at the end we'll just return the new numbers array. Now, what we can do is look instead if I can spell return correctly, instead of returning a list or like a object, right? We return the function, the whole function. See, what we're doing is we're returning this whole thing. Therefore, when we do something like, for example, let's do a thing called add 5, right? And we're basically just going to do a higher order add 5. So this will basically increment by 5. And now what we do is we see this is right now, this isn't a variable. This is a function. What this function is remember, this returns a function. Therefore, this equals assignment operator is actually add increment. So it will be more appropriate to say add increment by 5. So this will create a incrementer function, and this is where it all makes sense. Trust me. When we do something like add increment by 5, what we just have done is we're going to pass a list, again, numbers, and we're going to do something like this, and now it's going to add all of these numbers. So this will become 28 and 55. And yeah, I forgot I named it inc instead of increment. But once we run this again, you can see we have literally just composited two functions together, and that is what higher order functions are. So if you are familiar with math notation, that will just be, let me just do something like a thing right here. So this is equivalent of kind of like, if I can do this correctly, we'll set this higher order add, right? This is equivalent to like higher order add 5, which is another function passed in. Now what we do for this is we pass in this so like this list right here to this nested function, and then it's basically something like f of g of x. So like, again, composite functions in math. It's basically just that. So that is what higher order functions are. Alright, so I think that is enough of functional programming for today. Now, obviously, this is just the very, very basics of how functional programming works, the fundamentals, as you would say. But know what all these do, and next time we'll be going over another fairly fundamental thing, which are lambda expressions. And yeah, so if you enjoy this video or even mini series, leave a like and just tell me in the comments what you would like to learn within functional programming. And yeah, I will see you in the next one.